Problem number 1, it's just going to ask you to solve for x. And the problem will look something like this. 5 times x minus 3 minus 7x is equal to 4 times x minus 3 plus 9. So when we learned how to solve equations like this, we said that if there's parentheses, we distribute whatever number is in front. And if there's no number in front, we distribute 1. So in this case, the 5's in front, we'll distribute it here. We'll distribute the 4. We get 5x minus 15 minus 7x is equal to 4x minus 12 plus 9. Once everything is distributed, we can combine like terms on the same side. So this will be negative 2x minus 15 is equal to 4x minus 3. If we subtract 4x to get our variables on the left, and if we add 15 to get our constants on the right, we get negative 6x is equal to 12, and x would just be negative 2. Moving on to the second problem, I'll ask you to graph y is equal to negative 3/4 x plus 2. The way we talked about graphing equations is we said if it's in slope-intercept form, this second number is called the y-intercept, where it crosses the y-axis. And then the number in front of x is our slope. And it tells us whether we're going to go up or down, and then whether we go right or left, depending on the signs. So for a problem where it says negative 3/4 x plus 2, let's start by putting a point on the y-axis at 2. That's the y-intercept. And then if we have negative 3/4, that means that we're going to go down 3 and to the right 4. So down 1, 2, 3, to the right 1, 2, 3, 4. And then we just connect our points to get a line. Remember, a line is made up of 2 points. You just need 2 points in order to get a line. For problem number 3, it'll say to write an equation of a line with slope equal to negative 2 and a point that's negative 3, 5. So the way that we write the equation of a line is we always start off with our slope-intercept form, and then we plug in for x, for y, and for the slope. So if the slope is negative 2 and x is negative 3, our y is 5, that leaves the only unknown to be b. Negative 2 times negative 3 is 6. And then if we subtract 6 on both sides, we get negative 1 is equal to b. So the way that we take this and come up with an equation is we want to fill in for m and b. Those are what we have to fill in. And the problem tells us the slope is negative 2. And the b value is negative 1. That would be the equation of the line. Next problem, it'll ask you to solve a system. So solve the system 2x plus y is equal to 3, and x plus y is equal to 6. When we talked about solving a system, we talked about graphing, substitution, and elimination. I think probably the easiest thing to solve a system would be to use elimination. And with elimination, we want to get the same numbers, but with different signs. So if this is 2, we want to turn this 1 into -2, or if this is 1, we want to make this into -1. It doesn't matter which one that you transform. We transform by using multiplication. So what I'm going to do is I'm just going to multiply this bottom equation by -2. By doing that, the top equation stays the same. Bottom equation becomes -2x minus 2y is equal to -12. With elimination, we always add, so these will cancel. You get -y is equal to -9, so y would be 9. Don't get too excited because that's half of the problem. The other half of the problem is we want to figure out what x is. So if y is 9 and x plus y is 6, that means x plus 9 is 6, so x would be -3. That's how you solve a system of equations. Question?
You can also do the subtraction method that I think taught us for you. Just multiply the second equation by 2, then subtract the 2x, so the x's drop away. And you would get I think it ended up being -y is equal to -.
Yeah, so the question was, there are a few different ways that you might have been taught to do this. The way that I always taught it was that you want to get the same number opposite sign and then always add them. Some teachers that you might have had said you could get the same number and then subtract. But from my experience, students sometimes confuse the signs with that. So you could get the right answer doing the technique that you said. I would always encourage you to multiply to get the same number, opposite signs, and always add. All right. All right, so that's number 4. Problem number 5 says to multiply (3x minus 2y) times 5x plus 4y. When we talked about multiplying polynomials, we learned a method called the FOIL technique, where we multiply the first terms. So this would be 3x times 5x times the outer terms. So we're going to add 3x times 4y, and then plus the inner terms, -2y times 5x, and then add the outer terms, -2y times 4y. Remember, when we multiply the same variable, we have to add their exponents. So x times x is x to the second. So we get 15x squared plus 12xy minus 10xy minus 8y squared. We can only combine like terms if they have the same variables and the same variable powers, like these two. So we get 15x squared plus 2xy minus 8y squared. That would be our final answer. All our like terms are combined. Everything okay?
Yeah. It's an example.
Oh, yeah. All right, so that's number 5. There are a couple of factoring problems. So for number 6, it asks us to factor. And when we learned about factoring, there were 4 parts. We said we could take out a GCF first. Next, we looked to see if we could factor by grouping. Next, we talked about trinomials. And finally, we talked about special cases. And we always factor in this order. We don't jump straight to step 3. Just like if you were following a recipe, you would start with step 1 and then just kind of go down the list. So for problem 6, a factoring problem would look something like this. 12x squared minus 5x minus 2. Doesn't look like there's a GCF. We can only do grouping if there's 4 terms. So the way we talked about factoring using trinomials are we multiplied 12 times -2. And we're looking for numbers that multiply to be -24, and they have to add up to be -5, like -8 and 3. From here, what we could do is break up this middle term so we could factor by grouping. So instead of -5x, we're splitting it up into -8x plus 3 to get an even number of terms so we could factor this by grouping. If we cut it down the middle now and factor out the GCF of each half, we could take out a 4x and we're left with 3x minus 2. We could take out a factor of 1 and we're left with 3x minus 2. Completely factored, you write your new GCF, which is what's in common, the 3x minus 2, and then the 4x plus 1 is what's left over. This would be completely factored. Problem number 7 is a little bit of a more complicated factoring problem. It just asks you to factor completely. And this problem looks like this. 3x to the 7th minus 12x to the 6th minus 36x to the 5th. Well, the first step when we go to factor is to look to see if there's a GCF. And what is the largest number you could divide by 3? Or you could divide into 3, 12, and 36. 3. So the GCF here, 3 is the largest number that you could divide into each of these. And as far as the variable, we always go with the highest power. So it looks like x to the 5th would be the GCF. So if we divide everything by 3x to the 5th, we're left with x squared minus 4x minus 12. This. And that's nice. The problem with factoring is sometimes you have to factor multiple times. So we took out the GCF, which is good, but it looks like this is a trinomial, so we have to keep factoring. We're going to take this factor and look for numbers that multiply to be -12 and add up to be -4, like -6 and 2. So we could factor again by writing x squared minus 6x plus 2x minus 12. And it's like the gift that keeps on giving. Just keep going here, take out an x. And we're left with x minus 6. Take out a 2, we're left with x minus 6. So when it's all factored out, you do have the GCF, but then you have x minus 6, and you also have x plus 2. That is completely factored. Would I accept what?
Like if you do that X and go straight there.
Yeah, it's okay. So the question is, somebody in class was saying that they can go straight from here to here. And that's great. So there's all different techniques to factor. And if you could do that without showing the work, that's fine. Just a general rule of thumb is the more work you show, the more partial credit I can give you. So if you don't show any work and you get it wrong, I can't give you partial credit. Yep. Okay. So we'll keep going through here. Next problem is number 8. Problem number 8 asks us to solve for x. And we have x squared minus 8x is equal to negative 12. The way we solve polynomials is we make it equal to 0. So let's go ahead and bring the 12 over. And when we have a trinomial, we talk about factoring. And we need numbers that multiply to be 12 and add up to negative 8, like negative 6 and negative 2. So we'll write x squared minus 6x minus 2x plus 12. Cut it down the middle, take out an x. Take out a negative 2. And we're left with x minus 6 times x minus 2 is equal to 0. Now that's factored. The way that we have to solve this is we use what's called the zero factor property. And when it tells you to solve, what you do is you just make your factors equal to 0. And x would be 6. And x would be 2. So that's how you do problem number 8. Number 9, it asks us to divide. And let's say we had a problem where it's 64x to the 6th minus 24x to the 4th plus 32x squared, all divided by 8x. When you're dividing by a single term, what we do is we just divide every term in the numerator by that denominator. So what that means is we take 64x to the 6th, and we're going to divide that by 8x. Then we're going to take negative 24x to the 4th, divide that by 8x. And then take 32x squared and divide that by 8x. So the way that we divide now is we do 64 divided by 8 is 8. When you're dividing the same variables, you subtract their powers. So this would be x to the 5th minus 3x to the 3rd plus 4x. Problem number 10, it'll ask us to multiply and simplify. And let's say the problem was x squared plus 2x minus 3 divided by x squared minus 1 times x plus 1 divided by 2x plus 2. The way you would do this is you have to factor. So this trinomial here, we could look for numbers that multiply to be -3 and add up to be 2, like 3 and -1. So I'm just going to skip a step here. We've done a lot of factoring work, so we don't have to do it every single step for this problem. It's just x plus 3 times x minus 1. X squared minus 1 is actually a difference of perfect squares. So remember, if you take the square root, this just turns into x plus 1 times x minus 1. That was how we talked about doing a difference of perfect squares. Formula was a plus b, a minus b. And then we're going to multiply by x plus 1 over taking out a GCF of 2. This is what it looks like completely factored. And we're multiplying, so if you multiply by the same factor that you divide by, we could cancel out common factors. So x plus 1, x plus 1, x minus 1, x minus 1. Looks like all we're left with is x plus 3 on top and 2 times x plus 1 on the bottom. That would be our final answer. Problem number 11, we are going to add 6 over x minus 4 plus 5 over x minus 3. All right, just give me 1 second and I'll be with you guys here. All right, so for this problem, the way we add rational expressions is we have to get a common denominator. So our least common denominator needs to have a factor of x minus 4 and x minus 3. So we're going to force that to be in common by multiplying the numerator and the denominator of each fraction by whatever is missing. So the one on the right needs an x minus 4. The one on the left needs an x minus 3. So we wind up with 6 times x minus 3 over x minus 3 times x minus 4 plus 5 times x minus 4 divided by x minus 3 and x minus 4. And you could see that they do have the same denominator, so we can go ahead and combine them just to be one fraction. X minus 3 and x minus 4 is on the bottom, and on top, we're going to have 6x minus 18 plus 5x minus 20. And all together here, we get 11x minus 38 divided by x minus 3 times x minus 4. Problem number 12 would be a minus 5 over a divided by a plus 1 over a. And it's called a complex fraction because you have a fraction over a fraction within a fraction. The way that we get rid of all these fractions is you just multiply the top and bottom by the least common denominator. And it looks like the least common denominator for the whole thing. Well, the only thing in the denominator here is a. So if we multiply everything by a, it'll cancel out all of our fractions. We'll make sure that we multiply everything in the numerator and in the denominator by a. Because a over a is just 1. So we're not changing the value of the fraction, we're just changing the form of it. So if we go ahead and do this, a times a minus a times 5 over a divided by a times a plus a times 1 over a. We get a squared minus 5 divided by a squared plus 1. Problem 13 is similar. So we're going to be solving a rational equation. So I'll just ask you to solve for x. And it'll be negative 4 over x plus 3 plus 5 over x minus 3 is equal to 35 over x squared minus 9. In order to do this, we have to figure out what the common denominator would be. So let's go ahead and factor this perfect square, x plus 3 times x minus 3. And then we're going to multiply everything by the least common denominator. The least common denominator definitely needs an x plus 3. And it also needs an x minus 3. So your least common denominator is x plus 3 times x minus 3. It's going to be kind of a lot of writing. But the more work you show, the less likely you'll make a mistake. So I'm just going to go ahead and write x plus 3 times x minus 3 times each of these fractions. And by showing all the work, you could see all the denominators are going to cancel. You're just left with negative 4 times x minus 3. The x minus 3's cancel. 5 times x plus 3. And then 35. So let's go ahead and distribute like we did in our first problem, and we'll go ahead and solve for x. Negative 4x plus 12 plus 5x plus 15 is equal to 35. Combining our like terms would be x, and then 12 plus 15 is 27. We could subtract 27, and x would be 8. And now we're going to move on to radicals. Problem number 14, I wanted to go over two examples. One example is with perfect roots. So like the square root of 36, x to the 10th, y to the 8th. And then we'll do another problem where it's an imperfect root, like 52, x to the 11th. The way we talked about handling radicals is you don't do it all at once. You break it up into smaller parts. So square root of 36, square root of x to the 10th, square root of y to the 8th. And then you just do each individual piece. Square root of 36 is 6. For the variables, remember we're looking for groups of 2. So one way we could look at it is like just do 10 divided by 2 is x to the 5th. Or 8 divided by 2 is y to the 4th. That's pretty easy. That's how you do that. The next one is if it's an imperfect radical. And we talked about a couple different ways that we could do that. One way to do it is to look for the perfect squares that go into the radicand. So 1, 4, 9, 16, 25, 36, 49. We're looking to see what's the biggest of those that you could divide into 52. And I think 4 is the answer. So we could write this as the square root of 4 times 13. Thank you. Square root of 4 is just 2 root 13. Another way we talked about doing this, because 52 is kind of a big number, it's a little tricky to figure out which of these goes into that. One thing that I would do is I would just take 52 and break it up into prime numbers. So 2 and 26, 2 and 13. We could see that there's a group of 2 with a 13 left over. So either way, we get the answer using the two different techniques that we talked about. For the square root of x to the 11th, we're looking to see how many groups of 2 go into 11. 5, and then there's 1 left over. So we could say this is x to the 11 over 2, or x to the 5 1/2, or there are 5 groups with 1 left over. The way you would write your final answer for this is you would do 2x to the 5th times the square root of 13x. That would be the final answer. For 15, what if we had 2 plus 3 root 5 times 7 minus 4 root 5? So now we're not only simplifying radicals, we are multiplying them. So let's go ahead and multiply these out. 2 times 7 is 14. 2 times negative 4 root 5 is negative 8 root 5. Remember, when you're multiplying radicals, you multiply the outside numbers and you multiply the inside numbers. This would be 21 root 5. And then the last numbers would be negative 12 square root of 25. These terms are like terms because they have the same radicands. We talked about adding and subtracting radicals as long as they have the same radicands. So you have negative 8 root 5s plus 21 root 5s would be 13 root 5s. Square root of 25 is just 5. 5 times negative 12 is negative 60. So negative 60 plus 14 is negative 46. So when it's all combined, this would be our final answer. Negative 8 plus 21 is 13. That's how many radical 5s you have. And then negative 60 plus the 14 is negative 46. Usually we always write the radicals at the end. So that's what I would be looking for here. Problem 16 asks you to rationalize the denominator. And the problem will be like 6 square root of 5 divided by the square root of 3. When we talk about rationalizing, what that means is you can't have a radical in the denominator of a fraction. So what we want to do is multiply by something that matches the index with the radicand's power. So we want to wind up with the second root of 3 to the second. And the way that we could do that is to multiply by the square root of 3 over itself. Square root of 3 times the square root of 3 is the square root of 3 squared. And on top, it would just be 6 square root of 15. Like we said, the square root and the square, they cancel each other out. So we just get 6 root 15 over 3. And 3 goes into 6 twice. So your answer would just be 2 times the square root of 15. If you were to just leave it like this without simplifying, I'd take off half a point because it's not simplified. Problem 17, we're going to be solving for x. And it'll say the square root of x plus 3 minus 4 is equal to negative 2. When we're solving equations with radicals in it, you want to isolate the radical and then square both sides. So we'll add 4 to both sides. And we'll get the square root of x plus 3 is equal to 2. To get rid of a radical, we square both sides. And this is just x plus 3 is equal to 4. And x would be 1. Last problem I wanted to go over with you, problem number 18, is a word problem. So let's say a store sells 2 types of shirts. A fancy one sells for $26. And a basic one sells for $19. $13 shirts were sold, bringing in $310. How many of each type were sold? All right, so the way that we get started with any kind of word problems, we have to get organized. We can't just start throwing numbers all over the place. So the way that we get organized is we have to figure out what is it we're looking to find. We're looking to find the number of fancy shirts. And we're looking to find the number of basic. I don't know how many of each they sold, so we'll label them X and Y. Now we have to use our logical minds to try to convert this math talk to, to equations. So if 13 shirts were sold, that means the number of fancy plus the number of basic were 13. So we already used variables for that. X plus Y is 13. The number of fancy shirts plus the number of basic shirts were 13. Now that $310, that comes from, here, let's label it like this. Units sold, we'll say 13. This is total revenue. The way you figure out how much revenue you bring in is you take the number of shirts times how much each of them cost. For example, if you have a $10 shirt and you sold 3 of them, you'd bring in $30. So it looks like for this problem, fancy shirt, which we let be X, sells for $26. We don't know how many were sold, but 26 times the number of fancy shirts gives us the total revenue for fancy shirts. Similarly, for basic, a basic shirt sells for $19, but we don't know how many were sold. So we do have this system of equations now. The way that we learned how to solve a system of equations is you want to multiply to get the same number and opposite signs. So we could either try to get positive 26 and negative 26, or we could try to get positive 19 and negative 19. Doesn't matter. 26 was a better year for me personally, so I'm going to make the X into negative 26 by multiplying everything here by negative 26. I always draw my arches to make sure that I multiply each term by that. Sometimes if you forget to draw the arches, you might miss a term, but let's see what this turns into. This is negative 26x minus 26y is equal to 13 times negative 26 is negative 338. We did not change the second equation. And now because we have the same number and different signs, we could just cancel these out. Negative 26 plus 19 is just negative 7y. And this would be negative 28. Negative 338 plus 310 is negative 28. 28 divided by 7 is 4. So this means the number of basic we sold were 4. 4 basic. The number of total shirts we sold were 13. So the way that we figure out the number of fancy shirts sold would be x plus y is 13. We'll replace y with 4. And it looks like x would be 9. And that's the number of fancy shirts sold.